standard deviation of SAT scores on the reading portion is 112. A teacher believes, due to a new class in her school, the standard deviation has decreased. What would be my null hypothesis?
Standard deviation equals 112.
So what variable do we use for standard deviation? S for sample standard deviation or sigma for population, so technically either would be fine. The alternative, what parameter is being tested? It's just the sigma. It's basically saying, are you testing the mean? Are you testing the proportion? Are you testing a standard deviation in this case? Basically, like, what's your variable here? All right, do we call this left, right, or two-tailed? Left. Less than is left, greater than is right, not equal to is two-tailed. Okay, so suppose the null hypothesis is not rejected. If I asked you to write a sentence, so not just a fail to reject, but a sentence explaining, what does that mean? Does it mean I proved the standard deviation was 112? There is not sufficient evidence to prove the standard deviation has decreased. Okay, doesn't mean it didn't decrease, just means I couldn't prove it. Okay, D, if the standard deviation is actually 100, so if it's 100, should I have rejected my hypothesis? Yeah, but I didn't, so I made a mistake. So, which type is that? Type 1 or type 2?
Type 2.
Okay. Type 1, I told you it means you conclude H1. And that's how I remember it, the ones go together. In type 2, that means you have to conclude the null. In either case, we're wrong because it's an error. But look at, what did we conclude? If we did not reject the null hypothesis, which one did we use for our conclusion? Yeah, we didn't reject it. So if you conclude the null, that is type 2 error. That means we said that the standard deviation had not decreased, but it actually did. Any questions on that one? Okay. I want to test one by hand. So if I'm talking about P's, are we using Z or T? Z's. Okay. First, we always need to do what? Criteria. Okay, when we're talking about P, our criteria is that N times P times 1 minus P is what? And our sample has to be less than 5% of the total population. Okay, so N times P is 0.3 times 1 minus 0.3 is 42. So we're good there. And I gave you absolutely no information about the population, but we're just going to assume that it's less than 5%. So our criteria is met. So then what do we do? z-score. Okay. How do I get that? I'm missing some things. What do I need to find? Right, we need well, x bar is when we're talking about the means. We need p hat. Remember from my formula sheet, p hat is x over n. So 75 over 200 is 0.375. So it's p hat, or our value, minus the p in the null, divided by what? Standard deviation. So we need our standard deviation. How do we get that?
Square root of p times q, or 1 minus 1 over n.
Remember, guys, you can look at several different places on our formula sheet for this, but specifically if we're looking at like chapter 10, the test statistics, it tells you z is p hat minus the p of the null hypothesis divided by that whole thing. And we get 0.0324. So our z-score is 2.31. Then what do we do? Find it on the chart. So you guys can get out the formula sheets, look at that. This is a z, so we're looking at our normal distribution. So we're finding the probability. Are we looking for less than or greater than? Greater than, so we're looking for the probability that z is greater than 2.31. And I know that because my alternative hypothesis is greater than. How do we do greater thans on the normal table? 1 minus, okay, so 2.31. And that gives me what? Is that one okay? Right, I want you guys to write your null and alternative hypothesis on this one. We're going to do it on the calculator, so see how much you remember. So null. What's my variable here? Mean, which is? And then we want to test if it's, okay. If we're talking about mean, what's the criteria? Okay, so we met our criteria. Because we have 40. So then if I want to do this on my calculator, we go stat, tests. Which test do we do? The t-test, number 2. We're basing it off stats. The mean of the null is my 67. What is the x bar? 73. Ooh, I left out something, didn't I? Let's say the standard deviation was 3. My number is 40, and we are testing greater than. Ooh, that's too ugly. Hold on. Yeah, let's make standard deviation 23. That'll make it better. Okay, so then what do we get for the t value? The probability? 0.107. So what you do? Should I type something in? The mean of them. Did you guys do 23 for the standard deviation? Oh, I know why. I changed my standard deviation. I didn't change my other thing. Okay. So the p-value is 0.053. So, do we reject or not? No. When do we reject? So since p is greater than alpha, we fail to reject. All right, if I asked you to write me a sentence for a conclusion, what would you say?
There is not enough evidence to reject the null.
There's basically not enough evidence to conclude that people are withdrawing more money at the new machine. One last problem. In 2001, 38% of adults with children under 18 reported their family ate dinner together 7 nights a week. In a recent poll, 403 of 122 adults said that. Has the proportion decreased? So what's my null hypothesis? P equals 0.38. Alternative? Okay, if I'm talking about P, what criteria do I need to verify? What's my N? Okay, and that is, so we're good. We should verify that it's less than 5% of the total population, but on a lot of these we really can't check that, so it's kind of assumed that part will work. So, if I want to do this on the calculator, where do we go? Stat, test, which one? A. That gives us an interval. Number 8. Number 5. We have a 1 proportion z test. Since we're doing a hypothesis test, we need a test. You'll know if you pick the wrong one, because when you go into it, it'll ask you for things we don't have. So you can try a different one. So the p of the null is 0.38. My x is 403. My n is 1,122. We are testing less than. So the z value is 1.44. The p-value is 0.075. So please take the time to write down z and p so I know what you're basing your answer off of. So what does that tell me? Right. So that's kind of a run through of the different things we've been doing. We did something for the proportion, something for the mean. We've done both of them on the calculator, talked about doing them by hand. Are there any questions? So the rest of today, I told you, was time to finish that packet that's due tomorrow. So finish it. You can check your answers, ask questions, all that good stuff.